Welcome back, everybody. Today we're formalizing our knowledge of extreme values with something called the extreme value theorem. Kind of a big deal. Little collegiate, looks a little mathy. Here's what our theorem says. If f of x is continuous, that's a key component, on a closed interval a to b, then f of x has an absolute max and an absolute min. These are also sometimes referred to as the absolute extrema. You might recall from our last lesson, where do absolute extrema occur? These are going to be the places that we need to check when we are justifying our answer. Anybody remember from yesterday? Well, if it's a closed interval, the first place we have to check are the endpoints. That's a must. Okay, so as far as this first theorem is concerned, we're on a closed interval. If we're in the applications of derivatives chapter, we should probably check the derivative. Okay, good idea. Maybe the derivative is 0, or maybe the derivative does not exist. Now, we're never really sure what it means as we learn our AP plan. If you see the phrase justify, okay, what does justification look like in 2020? If you need to justify, you are going to make a table of all the possible candidates. Okay, so you're kind of exploring these three possibilities and where the winner is. Let's take a look at perhaps a function that we recall from one of our earlier differentiating. Now, when you are going through this, again, one of the key ideas here is that you are given a closed interval. So as you look at these questions, as you start to understand the difference in questions, I've got a closed interval. The other clue, it's a clue, is that in the directions, it will say to find the absolute extrema. As we go down the road and we look at some other cases in chapter 4, you might not have the closed interval, you might not see the word absolute. So those are going to be key differentiators, pun intended, of how to figure this out. When I make my table, I'm going to go junior high style. Okay, junior high style it is. I'm going to think through my three possibilities. You're looking at the values of the function. Where do points come from? The original function. So I start with my two endpoints. Now, just for argument's sake, it's kind of like we're on a baking show. I've already got the values for you, don't you worry. Recall in AP, we always round to 3 unless otherwise stated. I'm finding these values from the original. Okay, well, when all else fails, I should probably take the derivative. So I take my derivative. Good news, it's just a power rule. We just did real well on our test on derivatives. I get x to the negative 3/5. I would encourage you to write it as a fraction. It's going to be easiest to figure out zeros and undefined if you have your derivative as a simplified fraction. All right, self. When does the derivative equal 0? Well, what makes the fraction go to 0? The numerator is 0. Last time I checked, when did 2 equal 0? Whole lot of never. That's not giving me any candidates. When is the derivative undefined? Does not exist. When the denominator equals 0, which gives me a candidate of 0. Where do points come from? Points come from the original. 0 to the 2/5 is 0. After you've looked at all the possibilities in your table, it's time to come to a decision. Remember that phrase from the last video? Well, who's my absolute lowest value? Looks like 0 is the winner. I have an absolute minimum of 0 at x equals 0. That answers the what, the where, the why, the value, all the questions you need. Which one's my biggest value? 1.552. So I have an absolute max of 1.552 at x equals -3. All right, just for kicks and giggles. Anybody remember what this graph looked like? Not really in our mental curve collection, but we saw it before. It's a cusp. So if I were to think about my graphical knowledge, it should agree with my answer. At -3, I have 1.5-ish. At 0, I have 0. That's where my cusp occurred, not differentiable. At 1, I have 1. So on this closed interval, I have an absolute minimum and an absolute maximum. Now it's time for you to try some on your own, Pirates. Good luck.